Good morning. Welcome to session 1 on successive differentiation of important questions from previous year question papers. So today we are going to solve 2019 year question paper on successive differentiation. So let us take one example in this. If y is equals to e raised to minus x square, then show that yn plus 1 plus 2x yn plus 2n yn minus 1 is equals to 0. Let us take y is equals to e raised to minus x square. This one as equation number 1. So now let us differentiate this. Differentiating with respect to x, derivative of y is y1 is equal to derivative of e raised to x square is e raised to x square. We know derivative of e raised to x, we know e raised to x only. So in place of x we have here minus x square, no? So it is also same e raised to minus x square into derivative of minus x square, that is minus 2x. So therefore here this implies y1 is equals to, we know e raised to minus x square is nothing but y. So this e raised to minus x square is written as y and this minus 2x as it is. So it is, if you take this one in LHS, it becomes y1 plus 2xy is equals to 0. See here what we want? We want yn plus 1. So means you have to differentiate this n times using Leibniz theorem. Let us differentiating this equation n times using Leibniz theorem. That is nth derivative of y1 plus 2 is constant, nth derivative of x into y, and it is equals to 0 because nth derivative of 0 is 0 only. So we know nth derivative of y1 is yn plus 1 plus 2 into nth derivative of x into y. We know the Leibniz theorem. We know the Leibniz theorem here. Leibniz theorem is, you know Leibniz theorem, that is nth derivative of u into v is equals to u as it is nth derivative of v plus nc1 derivative of u and n minus 1th derivative of v, then plus nc2 second derivative of u n minus second derivative of v plus etc. up to u n up to un it is, that is ncn un. So means u as it is nth derivative of v plus nc1, differentiate this term and reduce the degree of derivative of v as 1, that is v. Applying nth derivative to this x into y using Leibniz theorem, we have this 2 as it is, x as it is like u into v. So as I have told you, nth derivative of u into v is like this, u into vn plus nc1 u1 vn minus 1 plus nc2 u2 vn minus 2 etc. up to un. So here x is u and y is v. That is x as it is nth derivative of y plus nc1 derivative of x n minus 1th derivative of y. And if you write one more term, see here derivative of x is 1. So if you differentiate this once again, suppose if you write one more term, then it will be nc2 second derivative of x and n minus second derivative of y. See here second derivative of x is 0 because derivative of x is 1, first derivative. If you differentiate this once again, it becomes 0. So you have to stop here only, don't write the next term. So no need to write this term. So you have to stop here only. It becomes yn plus 1 plus 2 times of x into nth derivative of y plus nc1 is n and the derivative of x is 1, n minus 1th derivative of y is yn minus 1. It is equals to 0. So it is yn plus 1 plus 2x into yn plus, open this bracket, it is 2 into n yn minus 1 is equals to 0. So this is only our required result. That is here if y is equals to e raised to x square, then its nth derivative, then it is n plus 1 yn plus 1 plus 2x yn plus 2n yn minus 1 is equals to 0. This is only our required result. Second example is, if y is equals to nth derivative of 1 by 2 is 0 and minus this 1 by 2 constant as it is, nth derivative of cos 2x is 2 raised to n cos 2x plus n pi by 2. So it can be written as here 2 raised to n divided by 2 is 2 raised to n minus 1 into cos n pi by 2 plus 2x. We know because this is the standard formula of nth derivative of this we studied. Nth derivative of cos ax plus b is equals to a to the power of n into cos of n pi by 2 plus ax plus b. So here ax plus b is 2x. It is simply 2x. So it is 2x as it is. So nth derivative of cos 2x is 2 raised to n cos 2x plus n pi by 2 is the required solution. Take one more. If y is equals to sin hyperbolic 3x into sin 3x, then find its nth derivative. First we have to convert this sin hyperbolic in terms of exponential function. We know sin hyperbolic theta is equals to e raised to theta minus e raised to minus theta divided by 2. In place of theta we have here 3x. So sin hyperbolic 3x is equals to e to the power of 3x minus e raised to minus 3x divided by 2 into this sin 3x as it is. It is equals to this 1 by 2 constant as it is, e raised to 3x, open this bracket, into sin x, sin 3x minus e raised to minus 3x into sin 3x. Now apply nth derivative for this. Nth derivative is equals to 1 by 2 constant as it is, nth derivative of e raised to 3x into sin 3x minus nth derivative of e raised to minus 3x into sin 3x. Here it is in the form of nth derivative of, we know here nth derivative of e raised to ax into sin bx plus c is equals to, this is a standard derivation. It is equals to, we know, under root of a square plus b square whole raised to n into e raised to ax into sin of n tan inverse of b by a, that is theta we can take here, b by a plus here bx plus c it is. Whatever it may be the variable we can take, here it is. So this one is, now here it is in the form of e raised to ax into sin bx plus c. Here a is 3 and b is also 3, c is 0. You just use this formula. 1 by 2 as it is under root of a square plus b square. That is here under root of a square plus b square is under root of a square. A is how much here? 3 square plus b is also 3, no, it is, that is under root of a square plus b square, that is 3 square plus 3 square whole raised to n. It is under root of 9 plus 9 is 18, that is under root of 9 into 2, it is 3 root 2. So this is 3 root 2 whole raised to n into e raised to ax. You see here in the formula we have e raised to x. So e raised to x means it is e raised to 3x into sin n into tan inverse b by a. The formula is, so it is n into tan inverse b. B here is how much here? B is 3 divided by a is also 3. So it becomes 1. That is 3 by 3. It is tan inverse b by a means 3 by 3 it is equals to 1. Then plus bx plus c. So bx plus c means the whatever we have here, sin of 3x is there. No, it is simply plus 3x. Then next minus. The same thing here also, it is in the form of e raised to ax. Instead of plus 3 here it is minus. This is the difference. So it is minus, same thing, everything is same. So it is also 3 into under root of 2 whole raised to n, e raised to minus 3x into sin n of tan inverse. Here a is minus 1, no, it is 3 by minus 3 is minus 1 plus this 3x as it is. So in these two, 3 root 2 divided by 3 root 2 whole raised to n. This is also same and this one is also same. So we can take it outside here. This is 3 by 2 whole raised to n is common, and this whole divided by 2. Here we have this whole divided by 2 is there. No, we can take this one as it is. Remaining terms, e raised to 3x sine of n. You know tan inverse 1 is pi by 4 45 degree plus 3x minus e raised to minus 3x into sine. Tan inverse minus 1 is minus pi by 4. So this 3x minus it is n pi by 4. So now this is only the required result, and here I have given the explanation. So because here tan pi by 4 value is 1, and again I have written the formula nth derivative of e raised to x sin bx plus c as I have explained here. Otherwise we can take this one as r to the power of n e raised to x sin n theta plus bx also we can write, where r is under root of a square plus b square and theta is tan inverse b by a. So both are same. Here I have written directly in terms of a square and b square. Here it is in terms of r and theta. So this is the required solution for this y is equals to sin e power 3x into sin 3x and its nth derivative. Let us take one more example. So this is based on the partial fractions. So y is equals to 4x divided by x minus 1 whole square into x plus 1. Then find yn. Here y is equals to, you write this one as it is. You have to resolve this one into partial fractions. So here first factor is repeated linear factor. So it is a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x plus 1. Now take LCM. LCM is x minus 1 whole square into x plus 1. I hope all of you know this, how to take LCM and all. So it becomes 4x is equals to a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1 whole square. Take this equation number 2. You have to find the values of a, b, c, and to find a you have to make b and c 0 together. It is not possible. So to make here to find b we have to make a and c together 0. So that is in these two terms x minus 1 is common term. So you make this one as 0. By substituting x minus 1 is equals to 0, we get this result. So that is, put x minus 1 equal to 0 or x equals to minus 1. Both are same in above equation. So it becomes 4 into 1 is equals to a into 0 plus b into here put x equals to 1. So 1 plus 1 plus c into here we have x minus 1. No? So x minus 1 is 0. This implies 4 into 1 is 4 and 2 into b. This implies b is equals to 2. Similarly, we have to find the value of c. So to find c, we have to make a and b 0. So in these two, x plus 1 is common term. You have to put x plus 1 is equals to 0 or x is equals to minus 1 in equation 2. So in this, you have to put x equals to minus 1. So it is 4 into minus 1 is equals to a into here it is x minus 1 is x plus 1 is 0 and b into x plus 1 is also 0 plus c into put the value of x as minus 1. So minus 1 is minus 2 whole square. It is plus 4. So minus 4 equals to 4c. This implies c equals to minus 1. To get the value of a, you have to put x equal to 0 in equation 2. In this, you have to put x equal to 0. So you will get this LSS is 0. It is a into 0 minus 1, 0 plus 1 and plus b into 0 plus 1 plus c into 0 minus 1 whole square. So it becomes like this. A into minus 1. Then plus b into 1 is b and c into minus 1 whole square is plus 1. So we have take minus a in LHS, it becomes plus a. A is equals to b plus c. This implies here substitute the values of b and c. It is b is 2 and c is minus 1. So 2 minus 1 is 1. This implies a is equals to 1. Now equation 1 becomes in place of a, b, c, you have to put the values of a as 1 and b as 2 and c as minus 1. Now we apply its nth derivative. So nth derivative of 1 by x minus 1 plus 2 as it is constant, nth derivative of 1 by x minus 1 whole square, then minus nth derivative of 1 by x plus 1. We know these two are simple. We know nth derivative of 1 by x plus b. So we can do these two as it is. But this one is not in that form. So you have to take this one in the numerator. It becomes here its nth derivative we can find separately. So it is in the form of, these two terms are in the form of nth derivative of 1 by ax plus b. We know it is equals to minus 1 raised to n into n factorial into a to the power of n divided by ax plus b raised to n plus 1. So this one, we apply this formula for this and this last term also. And here it is the second term. The second term is in the form of, it is in the form of nth derivative of, we know nth derivative of ax plus b raised to m is equals to, we know, m into m minus 1, m minus 2, etc. up to m minus n minus 1 into a to the power of n into ax plus b raised to m minus n. So this we apply here. So in place of m, we have here, if you take this one in numerator, it becomes minus 2. That is this constant 2 as it is, and this that is m is minus 2, no? So it is minus 2. Next one is minus 2 minus 1 is minus 3, and minus 2 is minus 4, etc. That is minus 2 minus n minus 1 into a here is 1, no? It is 1 to the power of 1 is 1 only, and x minus 1 raised to m minus n. Here m is minus 2 and minus n. We can simplify this one. Let us see the simplification of this, only the second term, that is 2 into, here first term is minus 2, no? That I have written here as minus 1 into 2. And second term is minus 3, no? That I have written here as minus 1 into 3, because minus 1 into 3 is minus 3. And minus 4 is written as minus 1 into 4, etc. up to, and last term is minus 1 into n plus 1. So here, and this 1 divided by that x to the power of minus 2 minus n can be written as, here if you take in denominator it becomes plus. So in all these terms here, minus 1 we have n times, so it is minus 1 raised to n, and this x minus 1 raised to n plus 1 as it is, and remaining term is 2 into 3 into 4, etc. It is up to n plus 1. So this 2 outside as it is, and it is minus 1 raised to n into 1 into 2 into, etc. up to n plus 1 is n plus 1 factorial divided by x minus 1 into x minus 1 raised to n plus 2. So you have to substitute this one in previous equation. So that is the simplified form of second term. It is like this. And in all these terms, minus 1 raised to n into n factorial is common. Write the remaining term. 1 divided by n minus 1 to the power of n plus 1 plus, here we have n plus 1 factorial. And I have taken n factorial. So we know n plus 1 factorial is nothing but n plus 1 into n factorial. As we know, this 5 factorial can be written as 5 into 4 factorial, no, like that. So I have taken here in from n plus 1 factorial, let us take n factorial outside and write the remaining term as n plus 1 and denominator as it is, and minus this 1 divided by x plus 1 raised to n plus 1. So this is the simplified form of the nth derivative of the given function.